First, we have to connect the probe to the terminal, labeled as output. Sine, square, triangle and sawtooth waves are 4 commonly used wave types. You can choose one as an output waveform, and its icon will appear on the right side of the display. As you can see on the oscilloscope, the wave frequency is 1 kHz. To change this, press the frequency button. When you are at frequency settings, you may adjust the frequency by adjusting the knob, or we may directly enter a number, then pressing megahertz, kilohertz, or the hertz button we can set the new frequency value. In this case, we set it to 5 kHz. The signal has 200 mV peak-to-peak voltage. When you are at amplitude settings, to change amplitude to 100 mV peak-to-peak, first enter the number. Then press Shift plus Volt peak-to-peak button. When Shift is not pressed, the device considers entered number as volts, not millivolts. Sometimes, it is desired to add a DC offset voltage to the signal output. Luckily, the device has the offset feature. The waveform seen on the screen is when offset voltage is 0. Since it has 100 mV peak-to-peak, when we shift it 50 mV it should oscillate just above x-axis. Another feature is the pulse width modulation signal, where the on and off time of the square wave is adjustable. Press Shift, then press the offset button. The duty is %50. As you can see, reaching %20 duty, we have a signal that is high for 1 square and low for 4 squares. In addition to 4 commonly used waveforms, we also have noise and arbitrary wave functions. Noise function, as its name suggests, generates noise. The arbitrary function generates one of the functions chosen from an arbitrary function list. Let's press the Shift plus arbitrary button and choose exponential fall as the assigned arbitrary function. As you can see, it generates exponential decay as output. Let's assign cardiac waveform to the arbitrary button. Now, cardiac function is assigned to the arb button, and as output, we have heartbeats. You may choose output termination as high impedance or 50 ohm. What high impedance and 50 ohm mean is explained in the video description. But briefly, the signal generator has 50 ohm resistance in series with its output. When we choose high impedance, this resistance is ignored. However, when the 50 ohm option is set, this resistance is not ignored and the signal generated has double the amplitude of its value displayed on the screen. To change termination settings, follow this path. Menu, System Menu, Output Termination and choose high impedance or 50 ohm. When we choose 50 ohm, as seen on the oscilloscope display, even though amplitude is 50 mV peak-to-peak, we have 100 mV peak-to-peak voltage as output. To test the response of our circuitry at different frequencies, we may sweep frequencies on an interval. Follow this path. Menu, sweep menu, and at the sweep menu, set start frequency, stop frequency, sweep time, and whether sweep should be logarithmic or linear. In this case, we set start and stop frequencies as 1 and 5 kHz respectively. Sweep time as 10 seconds and sweep type as logarithmic. To activate sweep mode, press Shift and Noise button. As seen on the display, frequency is swept between 1 kHz to 5 kHz. Some people do not like comma separators appearing after every 3 digits. Commas can be turned off at the system menu. As you can see, commas are not shown anymore. In addition to turning on and off the comma separator, we can quit the menu by pressing Shift plus Enter number buttons. When turning on, the signal generator may start with its default waveform, frequency, and amplitude settings, or it may start with the last configuration set by the user. Now, the device starts with its last configuration. Let's restart it and see if its output remains the same. However, following the path, menu, system menu, and power on, setting power on mode as default rather than the last state, the device starts with its default configuration.